Hello, and welcome to the Mutation Surveyor webinar on the Amplicon identifier feature. In this webinar, we will be reviewing the sample grouping options available in Mutation Surveyor software, which utilize specific Amplicon identifiers within the names of sample files. These identifiers can be used to automatically group more complex data into appropriate contigs, as well as identify specific regions of interest to amplicons. Settings that use the Amplicon identifiers were designed to assist users with grouping sample files into specific contigs when default grouping settings do not provide the desired results. When all of the file names in a mutation project contain an Amplicon-specific designator in the same character location, they can be used to manually group sample files into contigs. In addition, Amplicon identifiers can also be used to label regions of interest in GenBank files to ensure that the correct ROI is used for each Amplicon. The default settings in Mutation Surveyor group sample files into contigs based on sequence similarity and alignment to a reference file. Although the default parameters work well for most mutation projects, contig settings may need to be adjusted when amplicons do not assemble into the desired contigs. This is often the case when amplicons have a high degree of overlap and are incorrectly placed into similar contigs. After analyzing your files, you may check to see if the grouping of your samples is correct by clicking the drop-down menu of each contig in the browser pane. In this mutation project, amplicons spanning exon 10 of the BRCA1 gene are aligned to reference files. Due to the large size of exon 10, it was broken down into several amplicons to ensure the whole exon was sequenced. Each trace contains a sample and patient identifier, but also contains a specific amplicon identifier to indicate its location in the exon. We can see from this project that the default settings do not place the samples into the correct contigs. For example, contig 3R contains samples from both 11A and 11B amplicons. Contig 5F contains samples from 12A and 12B amplicons, and contig 10R contains samples from 17A and 18A amplicons. If we open the Project Reviewer report, we can get a better view of the overlap of the amplicons. When you choose to view all contigs, this unique tool enables you to view the position of all of the sequences in reference to the nucleotide string of the GenBank file. This graphical report indicates that there is a significant degree of overlap between many of the amplicons, such as 10A and 10B, and amplicons 11A and 11B. If we examine the file names in more detail, you will notice that the exon identifier is contained within the same range of characters in every file name. Each sample file has this identifier in positions 14 through 16, and these numbers can be used to sort the amplicons into proper contigs. By clicking the Rerun button, the Project Settings option will appear, enabling us to change the contig settings and utilize the Amplicon ID feature. Select the option to Use Amplicon ID to construct contig and enter the character range located in your sample files. This particular project contains the Amplicon identifier within characters 14 through 16, and those are the values I will enter into this option. If you are utilizing the Amplicon ID feature to construct contigs, we recommend that you also deselect the option to force into one contig. This option places sample traces that meet all the matching base criteria and differ in their starting positions by less than 300 base pairs into one contig, and it is not necessary for separating amplicons with a high degree of similarity. The Contig tab of the Mutation Project settings also offers options to pair forward and reverse samples based on matching file names. After sample files are grouped into proper contigs, this option can be used to ensure that the correct forward and reverse sample files are pairing. The option requires that your sample files have a rigid naming convention. For example, If your sample pairs have identical names both before and after the forward-reverse designator, the first option would be suitable. If your file names are identical before the forward or reverse designator, then the second option would be suitable. The forward and reverse BRCA1 samples in this dataset have identical names before the forward-reverse designator, so I will select the option to ensure the proper forward and reverse pairs match for the two directional settings. It is also important to know that Mutation Surveyor can most easily recognize the F and the R directional designators when the underscore is the character both before and after the F or R. After the samples have been analyzed with the new contig settings, you can see that the program now properly groups the amplicons into the correct contigs based on their amplicon ID. For example, amplicons 11A and 11B are now placed into separate contigs, and amplicons 12A and 12B are now in separate contigs. In addition, all of the forward reads are now properly paired to their matching reverse reads, optimizing bidirectional analysis for mutation detection. To conclude the webinar, we will review the benefits of assigning amplicon identifiers to specific regions of interest. This process is completed through the Advanced GPK File Editor tool, and it ensures that the proper ROI is assigned to the amplicon. This is especially useful for amplicons spanning a large target region, such as the example BRCA1 dataset spanning exon 10. This exon has a length of more than 3,000 nucleotides, and rather than assign one large ROI to the GenBank file, it was broken down into smaller overlapping ROIs that are each assigned to an amplicon ID. These identifiers are identical to the characters within the sample file names, and are all the same length spanning characters 14 through 16. With amplicon identifiers assigned, the program will ensure that the specific ROI will be assigned only to those sample files that also contain the amplicon ID. In addition, ROI values related to coverage, size, and quality will be assessed according to the individual amplicon IDs rather than one large ROI. This example displays the custom report for a BRCA1 GenBank file that does not have amplicon IDs assigned to the regions of interest. Instead, one large ROI was assigned to exon 10. You can see from this example that the ROI values are assessed relative to the single ROI for each trace. The starting and ending values are the same for each trace. The ROI quality values are very low, and the coverage values are listed as no for every trace because the ROI is too large. The second project contains amplicon IDs that are assigned to the individual ROI values. You can see from the custom report that each sample contains ROI values that correspond to the amplicon ID that is associated with the sample file. ROI starting and ending positions match the amplicon ID. Quality values are assessed relative to those ROIs, and the coverage values are also listed relative to the ROI. For more information or to receive a free 35-day trial of Mutation Surveyor and other Soft Genetics products, please visit softgenetics.com or send an email to info@softgenetics.com. Please direct any technical questions you may have on this product to tech_support@softgenetics.com. Thank you for joining me in this webinar.